Hello, welcome to my YouTube channel. Uh, this is coming after a long break since my last video. This time I am sharing with you this project which I did for a house alarm, and this project, well, I'm not going to share with you the code, but I'm going to share with you what you can do to use a microcontroller that is not supported by F66K22 for the project, because I have a board with that microcontroller on it. However, I made a terrible mistake and bent the microcontroller with an over voltage supply. I forgot to put down the voltage on the VDD pin. So, well, I'll show you the simulation that I did with this microcontroller. However, I'm going to change over to Windows 10 because my Proteus version does not support Windows 7. It's a 64-bit. This is the program coding using ldmicro build 5411. Right. The project uses UART communication, so it sends signals from the keypad to the control panel and from the control panel to the keypad, and this is the coding for UART sending and UART receiving. And you can actually use this microcontroller for coding, and then select any other microcontroller that you have to actually do the project. So the good thing about microcontrollers is they write to the port rather than to the pin number, so the pin numbers are different from one microcontroller to the other. I've actually done a similar project to this one, which I did with the STM32F745, where I wrote the code for the STM32F4 series and then used the STM32F7 series. This is a similar. I'm just sharing with you the PIC version of that same kind of technique, and then you compile this project using high-tech C for PIC. Compile using this one, that's the C file, and then you open this C file in Mplabx. Okay, you create a project and open this file in Mplabx. Okay, right, and then you have actually three files that are produced by ldmicro: the ladder file, and then the header file that is having the same name as your project name. Okay, right, so this is the chip that was on the board that I wanted to use. Okay, right, so this chip, later I try to adjust the voltage settings there because I couldn't get a programmer for it. So later on I made a mistake and then I blew this board. I wanted to test it and then show you how you can actually do this trick, okay, practically. But anyway, I'll do the simulation for it. Okay, now going to the Mplabx coding. Right, this is the copied C file for the project. Right, as you realize that I've actually made some changes. Okay, it will include the ladder, include the header file for the project, and then here I have also added the configuration file, which you produce using configuration bits here. Right, you find this configuration bit 2 here on the PIC memory view. Okay, you go there and then you get here, and then you actually can make this configuration view. The other changes that you have to make, you realize that I have taken out this configuration here because I have my configuration there on the header file there that I have created. And also to change the UART baud rate there, you must actually change the UART baud rate there to your choice. I think 9600 is usually the most common baud rate used. Right, the digital ports, yeah, you have also to make some changes on digital ports there, because the analog ports are by default activated, so they will not sense if you choose on your ladder program. You see that these are digital ports, but they are also analog, and the analog is actually activated, so that will not actually sense any digital input there, because it's by default analog, okay, or the analog, so you make them digital. I'll show you how. Okay, you do not need to change here, because this is actually a high-tech C code, which is understood by the Mplabx compiler, which is the XC8 compiler. Okay, I'm using the XC8 version 136. Okay, you can change your compiler toolsets here. So I've used this one. There was one issue with this version 136, because the peripheral support are actually found in version 134. I don't know why they are missing from my version 136 there. So you have to copy your peripheral support, or just copy everything from version 134 to 136, or use 134. I was in Windows 10, so I had not installed this version 134 there, so I copied from this version 134 into version 136, which I had chosen. Okay, so yeah, that's one thing with the compiler that I actually found to be not working with me. So that was my solution. Okay, so this is how you choose your compiler there. Okay, that's the compiler for the project. You also realize that I took out the frequency configuration from the ladder. Okay, this is the ladder that the ldmicro produces. I took out this frequency configuration there, and then put them in my config. Okay, I actually put them here. Okay, I cut from the ladder file, header file, to the my config header file. Okay, so that's the change that I made on the ladder, and yeah, okay, nothing else on the ladder except also here I actually took out a comment on define external everything there. I think it doesn't make any change that much, and also the target here I've actually changed it to the PIC 18F66K2. Right, so those are the changes that you have to notice that I made. Okay, all the configurations there taken out, and then okay, so those are the changes that I made to the ladder file. And then most importantly, the changes that I have made also is actually here on the user lib C, the C file for the user library. Okay, I've actually changed here on the digital to analog, sorry, from analog to digital, to make analog ports digital. This is what I did. I think there is a better way of doing this using, I think, Atcon port bits. Okay, and then you actually select or you choose which bit should be set. Is it set, or it's a reset? Okay, so I did the long way. I think there's a better way of doing that. Right, this is the right justification that I did. Okay, and then okay, on this one I did the right justification. Right, so there was a change there, because the original file from ldmicro is different. It's actually made for the PIC 18F4520, and here also you can see that I have changed the target. Okay, right, this is what I did, the changes that you have to make on the user lib library. Okay, and then the other change that you have to do, okay, you add that my config, include my config there, because that's where the frequency is. Okay, the frequency definition is, because here you need the frequency definitions, because there is the timing adjustments that this file does. Okay, I think on the get prescaler there, frequency of the microcontroller there. Okay, so you will need this in my config. That's where the frequency is. By default, it had actually added the ladder file. Okay, but I took out the frequency definition there. So the other change that I made is here it was divided by 4 here, because I realized that every frequency that I defined, the microcontroller was running at 4 times less the speed. So the baud or the UART communication between the control panel and the keypad was not working until I had to make the microcontroller on the software that is on Proteus to run at 4 times less, or divide the frequency by 4. What I mean is, on my config here, if I choose to run the microcontroller 64 megahertz, I had to actually input 16 megahertz on Proteus, so that the watt signaling would work. Okay, so here I had to change to divide by 1 here, so that the frequency of the microcontroller and the frequency of the watt signaling is actually equal. Okay, so this was one change that I made, and then the other changes that I make, you realized here there is now a 0. It was a 1 there. Okay, there was a 1 there, made it 0, so that you have an output. This is the transmit, so it's an output, and then here is set, this is the receive. Okay, so it's an input, right? And then here you see that I've actually put 1 there, because ldmicro by default it has got that one, and well, this one it does accept. I don't know whether it will really change much. Okay, but it was accepting it without a 1. Okay, but there you need to change there to put a 1 there, unable to resolve the identifier. Okay, I put 1 there, and I think here as well. So these are the changes that I make. Okay, you compare with the watt lib C, that is without additions. Okay, compare with the original. Okay, compare the watt lib original with this one, with the one that I've actually used. Okay, and here you see that I was adding one where there was some error on my file there. Okay, right here also there is that one. Okay, because this is coming from a data sheet. Okay, if you refer to the PIC 18F 66K22 data sheet, you must put a 1 there, so that, because this microcontroller has got 2 UART ports, or 2 UART functions. Okay, so you have to choose which one you are going to use. Okay, and also here you see there's 1 there, and here there's the receive 1. Okay, right. So these are the changes that I made. Okay, to the files. Okay, right. What else would I share? Okay, I think that is as much as I can share. Okay, and then you compile, and then this code will not fit into the PIC 18F 4520. It will not fit, but in this 66K22 it will. I think this peak is what I think it's a 64 kilobytes. Yeah, 64 kilobytes of flash memory, and the 18F4520 is 32 kilobytes. So right, I think that's what I can share with you. Okay. Oh, right. Oh, the other part. Okay. Before I forget. Okay, the configuration bits. Okay. There's one challenge that I had. Okay. If I set the frequency oscillator source to be internal on my simulation on Proteus, it was not working. I had to change to the external high speed. And that was one thing that I couldn't find why the simulation was not working with the internal oscillator. Maybe I was supposed to set up the bits, the oscillator control bits, but I did put them there, but it was telling me that you are actually double defining the oscillator control bits, the OSCON bits. I think it's the RCIF, I think, yeah. The OSCON bits, RCIF, I think that's the bits that I tried to define here, but it was telling me that we are redefining it, so I took them out. Then I turned off the source frequency source bits here. This one, well, there was no contention with the compiler, right? And this is the settings that I did with the configuration. Okay, this is my configuration setting. I'll show you the simulation. Thank you.